Part I. Given that y is greater than 0, find the integral of 3y minus 4 over y times 3y plus 2. So, first thing we're going to need to do is to split this up into partial fractions. So I'm going to rewrite it as a over y plus b over 3y plus 2. Now combining that back together, we'll have a times 3y plus 2 plus b times y, all over y times 3y plus 2. That must mean then that my numerator has to equal 3y minus 4. So a times 3y plus 2 plus b times y is equal to 3y minus 4. If I let y equal 0 first of all, that's a good thing to do because that makes this term here become 0. So that's just going to tell me that a times 3 times 0 plus 2 is 2 equals 3 times 0 minus 4. So a has to be minus 2. So I can replace that there. Let's now work out what b is going to be. To do that, I'm going to let y equal minus 2/3, so that this term will disappear. So I get b times minus 2/3 equals 3 times minus 2/3 minus 4. Excuse me. So b times minus 2/3 is equal to minus 6. Timesing both sides by 3, I find that b is equal to b times minus 2 is equal to minus 18. So b is 9. So I can now put that in the original expression. So after all that working out, I have found that this integral can be written as the integral of minus 2 over y plus 9 over 3y plus 2. Now we can integrate each of those terms with logarithms. So the first term will get minus 2 ln y. The second term will have 9 ln 3y plus 2, but by the reverse chain rule we have to divide by 3 because of the 3y plus 2. So dividing the 9 by 3 will give 3. And let's be careful, let's not forget the plus c constant of integration here. And that is my answer for part A. Doesn't say I need to leave it in a particular form, so I'm just going to leave it like that. Right, part II. Part A. Use the substitution x equals 4 sine squared theta to show that the integral from 0 to 3 of the square root of x over 4 minus x can be written as lambda times the integral from 0 to pi over 3 of sine squared d theta. Right, so whenever we're doing integration by substitution, first thing I'm going to do is deal with the dx. So I'm going to take my x function, the x substitution, the 4 sine squared theta, and differentiate it. To help me differentiate it, I'm thinking of it as being 4 sine theta all squared like that. This is exactly the same thing as that. But by writing it like that, it just helps me to see the chain rule a bit more clearly. So differentiating the squared function first, that's the outside function. So I get 8 times sine theta. The power now is just 1. But by the chain rule, I need to multiply by the derivative of the inside function. The derivative of sine is cos. So this is my dx by d theta. So therefore dx is equal to 8 sine theta cos theta d theta. So this is going to get replaced instead of the dx there. I now need to do the limits as well. So when x equals 0 for the lower limit, 4 sine squared theta would have to equal 0. So that means that sine squared would have to equal 0. So sine theta is going to equal 0, which means that theta is going to equal 0. When x is 3 for the upper limit, 4 sine squared theta equals 3. So sine squared theta is equal to 3 over 4. So sine theta, square rooting both sides, is equal to root 3 over 2. So sine inverse of root 3 over 2 is pi over 3. So when we had 0 as my lower limit for x, I'm going to have 0 as my upper limit, as my lower limit for theta. And where we had 3 as an upper limit for x, I'm going to have pi over 3 as an upper limit for theta. Right, let's now do the whole substitution. So let me come down to the bottom here. So like I say, instead of the 0 for x, we've got the 0 for theta. Instead of the 3, we've got the pi over 3. We've then got the square root of x, which is 4 sine squared theta. So all I've done there is just swapped this x with the 4 sine squared. Then on the denominator, we've got the 4 minus x, which is going to be 4 minus 4 sine squared. And remembering that this is going to be multiplied, this still needs to be multiplied by the dx, which I'm replacing with 8 sine theta cos theta. Excuse me. Right, now let's try and simplify this a little bit. The denominator, I've got 4 minus 4 sine squared. I could factorise 4 outside of that. If I factorised 4 outside of that, let's see what that would look like. It would look like this. 4 lots of 1 minus sine squared. Which the 1 minus sine squared is then going to become cos squared. So I can replace that 1 minus sine squared with cos squared. So my denominator just becomes 4 cos squared. We can now see that those 4's cancel out. And we get left with the square root of sine squared over cos squared. So the square root is going to cancel the squareds and just leave me with sine over cos. Not forgetting that that needs to be multiplied by this 8 sine theta cos theta. So the cos thetas here and here cancel out. And that just leaves me with the integral from 0 to pi over 3 of sine theta times sine theta, so sine squared theta, multiplied by the 8, which I can put on the outside here. And there we go. That's what we needed to show. So lambda is 8. Obviously, it's a show that question, so you would need to show all of those steps line by line. I didn't have space on my screen, so I've not shown all of those. I rubbed out and went as along as I went. But if you need to get all of those steps, go back and re-watch that again, because that was a bit tricky, I know, and I went quite fast. Part B. Hence, use integration to find the answer to that integral. So basically finish off the integral that we found in part A. Remember that we found that lambda was 8. So how do I integrate sine squared? Well, I use the cos double angle formula. Remember that cos 2 theta is equal to 1 minus 2 sine squared theta. So therefore sine squared theta is equal to 1 minus cos 2 theta. So sine squared theta is equal to 1/2 minus 1/2 cos 2 theta. So I can put this in here instead of the sine squared, which will give me 8 times the integral from 0 to pi over 3 of 1/2 minus 1/2 cos 2 theta. Now, rather than me having to deal with these halves, I'm actually just going to multiply through by 8 here. Usually putting the 8 on the outside means that you would times by 8 at the end, but I'm actually going to times through by 8 here, just so I don't have to deal with those fractions. You don't have to. You could carry on working with the fractions and then multiply by 8 at the very end. It's up to you. We're now going to integrate. So the 4 will integrate to be 4 theta. Cos integrates to be sine. So we would have 4 sine 2 theta. But by the reverse chain rule, I need to divide by 2 from the inside here. So dividing by 2, we'll have 4 divided by 2, which is 2. Now to substitute the limits in, so we've got 4 times pi over 3 minus 2 times sine 2 times pi over 3 minus 4 times 0 minus 2 times sine of 0, which gives as our answer 4 over 3 pi minus root 3. And that is my answer in the form required. A is my 4 over 3, and B is the minus root 3. So we're done.